Hello and welcome. This video is about a whole world of data. We are in a data abundant world. It comes in all shapes and sizes, and we must support people to get engaged with the data that's all around them. Statistics and data science training needs to include a range of realistic data to prepare students for the real world. R provides easy access to an incredibly rich collection of datasets. It also can import many different types of data. So, the internet is your passport to data from all over the world. Your options are so many that the choice can be overwhelming. Here we help trainers and students to understand more about the types of datasets and hence choose data they might use. Explore and be curious. There is no danger in opening and looking at examples. You may find ones you like or decide they are not for you now. You have nothing to lose and potentially lots to gain. All the datasets from these R packages are available from within R-Instat. So, you do not need internet connection to access them. What about me? Are they also available from RStudio? Absolutely. In tutorial 1, we use the diamonds data. Open it again here. Click on Import from Library on the opening screen or in the icon toolbar. Select the package ggplot2 from the drop-down list. Notice that this package provides access to 11 different datasets. Select the diamonds data and click OK. This is an all-purpose dataset. It has factors and numeric variables, though most are numeric. This contrasts nicely with survey data we show later, which often has lots of factor variables. It is already tidy and therefore it is a great example for showing lots of data visualization. It is a nice size, bigger than many students have used in training courses. In contrast to agriculture type datasets, there isn't one obviously special variable to analyze, so it can be taken in lots of directions. Here, we show an unusual graph with a factor variable on each axis. Go to Describe, Graphs, Scatter Plot. Make color the Y variable, clarity the X, and cut the by variable to produce color to the graph. Choose the option to jitter the points and press OK. And are fun. Perhaps you could look for the R-Tidyverse documentation which gave the idea. They filtered the data to consider diamonds of more than 1 carat. To do this, return to the dialog, click on the Data Options button, then define New Filter, make carat greater than 1 as a filter, accept the condition, and press Return twice. Then press OK. Some packages supply a single dataset. The excellent Open Air package provides tools for the analysis of air pollution data for 65,000 hours of data on wind and pollution variables from London from 1998 to 2005. I'm really concerned about climate change, and pollution is also a big problem where we live. I could get more interested in data if we used some of these examples. Could we use records from our own country? Great question. It's almost like I planned it. The answer is probably. Type the name of your country and air quality database into a search engine and see what comes up. I just tried typing in global air quality data and I found that the WHO has ambient air quality databases which you can download here. This is exactly what is so exciting about this data age. Use R as your starting point and then go on a hunt for any topic that interests you. The R packages starting with SJ all have the same simple example of survey data. This introduces value-labeled data, which is how some statistical software like SPSS treats factors. In R, these are usually changed into factor columns early on. Data that is originally from a statistics package often also includes informative variable labels, which we are happy to see. We wish more R users would take the hint. Often, instead, we find the variable name is long, but this messes up the display. Using variable labels is a neat solution. With survey data, the variable label often gives the whole question. The Question R package provides access to more survey data examples in both French and English, and including data from the happiness survey. This is a good example of a dataset that is primarily factor variables, with just a few numerical columns. Analysis will include tables of frequencies and percentages. These can also be shown as bar charts. Next are datasets for specific points. The dataset package is an R package which just provides data. It provides a comprehensive collection with general datasets of different types, as well as some datasets designed to illustrate specific statistical points. For example, the set called Anscombe is famous for demonstrating the need for graphical displays and not just summary statistics. The R help explains why. Its 4 datasets are different but have identical mean and variance, even correlation and regression equation. This same point is illustrated in a more modern way in the nicely named Datasaurus package. Open the Datasaurusdozen file. Use the right-click menu to make the dataset variable a factor. Open Describe, Graphs, Scatterplot. Add the Y variable to the single variable box and X to the X variable box. Add the dataset variable to the by variable box for color. Then click on Facet By and add datasets. Then click OK. Now I understand the name of the package. And do each of these datasets also have the same mean and standard deviation? Yes, and correlation and line of best fit too. It shows how important it is to include a graph. Isn't it incredible how different these 13 datasets are? It is amazing that they all have identical traditional statistics properties. I'm impressed how easy this is with the ggplot graphs. The same package can be used to explore Simpsons paradox. This is another important idea which illustrates that results can be misleading if your model is too simplistic. You can use the R Help button to get more information on the concept. Return to the Open from Library dialog and this time select the Simpsons paradox dataset. Now repeat the same steps. So, make the dataset variable a factor, then complete the scatterplot dialog, including the facets as for the dinosaurs.
I can see the two sets are totally different.
Yes, like the dinosaur example, the two sets have identical summary values. So the means, standard deviations, correlations, and the regression line is the same. Return to the dialog and add the line of best fit with the standard error. Then press OK.
I can see the regression line seems sensible for the first set, but totally wrong for the second.
Yes, it is the second set that is an example of Simpsons paradox. There's clearly another variable which divides the data into 5 or 6 groups, and they each have a negative slope. So, the overall positive slope is very misleading. If you want to learn more about this concept, Wikipedia as usual provides a good source of information. Apparently, in 1973, the University of California discriminated against women as is shown in this table. They admitted only 35% of women applicants and 44% of men. However, this summary ignored the different admission rates in different departments, with more women applying to the very competitive departments. With this being such a well-known dataset, we wondered if it might be available in the Datasets package. Reopen the Import from Library dialog and select the Datasets package. Scroll through looking for something related to admissions. There is a UCBAdmissions dataset, so try it. Analyses include tables of frequencies and percentages. This can also be shown as bar charts and provide opportunities to explain why pie charts should be used sparingly, if at all. Next are datasets from books. The Introduction to Data Science book, which we really like, has a partner package called dslabs. You can buy the book or use an online version here. We really like the coverage of data visualization and data wrangling, tidying for statisticians in this book, so could consider other examples of data from there. Good, here's data science, so shows internet data and some big data. Only one of his 30 examples is larger than the diamonds data. It has now become 2 books and shows there is much more to data science than big data. But let's get to the biggest there is. It's on movie ratings. Return to the Import from Library dialog, choose the dslabs package, and select the movie lens dataset. Then click on the R-Help button to read about the dataset. From here, you can click on the Index button to go to a full list of dslabs datasets. Click on any of these to read about them and use the right-click menu buttons to navigate back and forward. I see historic CO2 provides atmospheric carbon dioxide concentration over 80,000 years. That could be interesting in relation to climate change. Yes, there's really all sort of interesting data in here, ranging from divorce and murder to Trump's tweets. And that's an obvious internet offering. Next is data from book references. And another source of data is to use the references in this or other books. For example, This is an interesting graph from chapter 11. It is one of the dslabs datasets, but by looking at the references at the bottom of the page, we can also see it came from Tycho. Follow the link provided, register, and the full data and more can then freely download. The data imports easily into R and is larger at 760,000 rows than the dslabs summary. We use this data in our presentation on graphs. Next is agriculture data. There is a popular trilogy of packages if your interests include the design and analysis of experimental data. AgriDat is just data and has lots of it. Examples include experiments on popular crops, trees, and animals. AgriTutorial has 5 examples and illustrates the analysis of each of them. Agricolai is very popular for the analysis of agricultural research data. It combines many commands for the analysis with a range of datasets. Choose the AgriDat package and select the Gomezsplitssplit dataset. These data are in all 3 of these packages, but we prefer the version from AgriDat. It includes the information on the layout of the experiment as we show here. That's something we don't see often enough in case studies of analysis. This layout information is useful when we discuss the experimental design. It can also help in analysis to see whether any anomalies in the data can be explained by their position in the field. We use AgriDat and Agricolai in the presentation on the ease of using scripts in R. The interaction plot shown here is also a reminder that R has powerful alternative graphics systems in addition to the ggplot graphics we usually use. Next is data from lists. A few packages provide data differently, so they don't come via the import from library dialog. Examining lists of items on different topics is also data. This is accessed via the New Data Frame dialog. Open File, New Data Frame, and click on the Lists tab. In the Animals list, there are other animals if you don't especially want birds from Antarctica. Use the drop-down menu to see. Then, use the Category drop-down menu. There are many other categories, a few of which we examine in the Fun with Lists presentation. Go to Geography as an example and select Canada, in case you might like to travel there. Next are datasets from outside R packages. We look at the mixed data. Examples don't have to come from R packages. UNICEF mixed surveys are an excellent source of data from around 100 countries. The data are provided as SPSS files, and there is a full presentation available on accessing mixed data and importing them into R-Instat. We show data from Pakistan as an example. These are considerably larger files. The household file is called HH and has about the same number of rows as the diamonds data, but it has over 300 variables compared to just 10 for the diamonds. There are also 8 data files overall. The HL file is for the household members in the survey and has about 330,000 records. These are very rich data. This is the first half of our video tour on data. We examine more examples and more types of data in the next presentation. And there is further information in the R-Instat help file. I begin to see the case for R in our university. There isn't really a problem with what is in our statistics courses. It is what we are not teaching that's the problem. Without realistic data sets, our students are just not being prepared for their work in the real world. Aha! And what's included in data science teaching before they get to machine learning may be part of the answer. Data science, that's me! We use big data to fuel our machine learning and AI algorithms. Data is the new oil. That is true. Though you also stress the idea of big data. But data is just data. Ideas that apply to big data are mostly the same as those that apply to medium and even small-sized data, so it is worth including this during training. At my university, we still teach with toy examples that illustrate individual points. Is the diamond's data big? No, that's still trivial. You couldn't fuel anything with that. That's correct. It is medium-sized, but it is big enough that there are many new complications to explore compared to the toy examples often used in teaching. And it is important to note that most of our knowledge comes from studies of this sort of size. You're saying that data should be central to our teaching, irrespective of the subject area or methods of analysis or the tools we use. Absolutely. It is also interesting that some of the early machine learning or artificial intelligence studies became AI scandals on gender or race. They drew the wrong conclusions because they were not looking carefully enough at the structure of their data. So, it is important to grasp good statistical methods using medium-sized datasets before diving into machine learning and AI algorithms. I use Python, not R. Should I be learning R? If you're only working with big data, then probably no. And I think Python can make use of R, so you may also be able to use these examples too. Nevertheless, many of the concepts of working with data don't change with size, so we hope some of these ideas remained interesting to you. We also like this book, which uses both R and Python. Why this book specifically? Coming from statistics, we believe it is essential that the analysis should depend on the structure of the data. The most basic element of structure is the difference between categorical and numerical columns in the data. R calls categorical columns factors and deals with them very well. So, to find a data science book that has the structure of data and factors on page 2 was already a winner for us.